Alright, it's OOP time. Alright, so now what we did early on was functional programming, where I showed you um, how to create functions, arbitrary functions, keyword functions, and lambda functions, all those stuff, map filters, all those kinds of functions. Alright, now object-oriented programming, it's another kind of programming. This is, should I say, it's a little new compared to functional programming, and it's efficient. Okay, it helps you to organize your code in a way that um, Python. When you look at Python by itself, you realize that most of the times we always do stuff like um, let's say, okay, can I can I try something like this? Import math. Most of the times you see something like math dot, and it gives you a lot of stuff. Okay, good. It gives you a lot of stuff. Now, what's this math? This math is a class. All right. Now, this class has children, or what we call methods or functions or properties. Okay. Now, this math has properties. So when I click on the dot allows me to be able to access these children or these properties. So when I click on dots, then these are the children that are inside this math function. So inside a math function, I can do all these kinds of stuff. So let's say I probably want to do square root, math square root of 2. There's a function or a property of this math that allows me to do that. Okay, so basically this is object-oriented programming, and it's quite efficient than we've been doing with the other kinds of programming. It's another way of programming, and I think this is where you should concentrate on mastering. Okay, if you're able to master object-oriented programming, then you can learn almost all the languages, because nowadays almost every language is kind of object oriented. Okay, and basically to help you organize your code. So let's try. So first I want us to create a class of a point. Okay, and then we'll use this point class to create another class called segment or line. Okay, let me call it line. All right, like this. So to create a class, just like a function, you start with the identifier called class. Okay, then you give it the name of that class, whatever name you want to call it. Class point. It's good to start the name of the class with a capital letter, right? It's good to start that way. So class point. Now this is a class, so I could just say class point. I could just say name equals to point 1. Okay, name equals to point 1, like this. Okay, so this is basically how a class is. I think I've already shown you a little about classes in the previous videos, but I want to take you from scratch again. So if I say name equals to point 1, and I come and say create an instance of this class. Now print p. Okay, print p is just going to give me the instance of the class. When I say print p dot name, then it will give me the results of p dot name point 1. All right, so now what I want you to understand is basic stuff. This is called a class. This is called an object. What's the difference? Well, the difference is just that this one, it's more of a blueprint, or let me just say it's a template. Okay, it's a template of how a point should look like. In this case, what you're telling is that anytime you are creating a class called point, anytime you are creating anything called a point, any variable called a point, that thing has a method, or it has a property called name, and so you give it the name point 1. All right, so that's basically how it works, but this is not exactly how classes would be for you. So in this case, when you create a new class, most of the times you need to give it an initialization. Okay, so underscore underscore, these are called under methods. Init underscore self. And don't worry, I'll be explaining all these things very soon. They will make sense to you a lot. Right, for now, let's pass. Alright, so now This initialization method is like the first thing to do when you create an instance of this object called point. So I'm going to create an instance of object called point. So let me say new point. I'm going to call it new point. Make it like this. New point like this equals to point. Alright. New point equals to point like this. Alright. So I've created an instance. Note, in the event where you're creating an instance of the class, it's called an object. But in the event where you are creating or defining, let me say defining the class, it's called a class. All right. So here it's an object. Okay, so over here it's an object, but over here it's called a class because this is the defining stage and this is the usage stage. Okay, so whenever you hear me saying class, I'm talking about the defining stage, but maybe sometimes I might interchange it. Doesn't really matter. The point is, so for here, this initialization, what it does is, the first thing you want it to do is would be put inside here. So when I'm initializing this, let's say I want to give this point a name. Okay, so I'll take some parameters here, and this point will have an x, right, and a y, right? So that's how a point is defined. A point has an x and a y and a name. Or maybe let me bring the name lastly. Okay, so that the x and y can come first, like this. Okay, so this class has an x and y and a name. So over here I'm going to say self.x equals to x, and don't worry, I'll be explaining all these things very soon. Self.y equals to y, and self.name equals to name. Now, what is self? Self means this guy, the whole class. Okay, it's basically a representation of this class, or let me say current class. Let me call it current class. Okay, call everything here current class, like this. Current class and current class, like this. Current class, current, oh, I wanted to call it current class, so current class, like this. You can name it any way you want to, but it should be consistent. Okay, so this self means current class, or well, you are giving how do I call it? It's some kind of recursion. Okay, you are giving itself as a parameter to itself. I don't know if that makes sense, but don't worry, you get it as we move on. So it's some kind of recursion. You are giving itself as a parameter to itself, and then you are giving it some other parameters of itself. So it has an x, it has a y, and it has a name. All right, so I'll just go back to using self because that's more conventional for me, and that's more self-explanatory. Okay, so self.x, it means that for this particular point, its x is the x the user will give, its y is the y the user will give, and its z is this and its name is the name the user will give. All right, you can give it as many parameters as you like. You can give it a z parameter, you can give it I've already given z, you can give it whatever parameter you think, but just that our point, we're going to define our point with these three parameters. Okay, so that's set for a point. Now you have a point, let's just go ahead. So now when you want to create a point, in this case, because it's taking parameters, you actually need to give it parameters. So let's say we'll give it the x part, then we'll give it the y part, then we'll give it a name, right? So over here the name will call point1, like this. I hope that makes sense. Okay, yeah, so that over here you can come and say print, maybe for the new point you want its name. So you can see that when you use the dot notation, it gives you all the children or all the characteristics of that class, just like we tried with the math function, okay, with the math class. So you can say print the name of the new point for me, and to tell you that the name of the new point is called point 1. Or you can say print the x-axis of the new point, and to tell you that the x value is 23. I hope that makes sense. Okay, it may not stick in well with you right now because we are not really doing any but this is a real world example because you can use it to create data structures and stuff. This is basically a data structure you're creating, geospatial data structure. This is an implementation of it over here. Yeah. All right. So I just got an idea from what I showed you here. So let's say, apart from defining its general parameters, you want to also give it some more functions. Let's say every point, you can display every point on a graph. So let's say show graph. Okay, show graph like this. Okay. All right. So over here, before you do that, you would have to import a library. So I'll import it within this function, just in case. I'll import it within this function. So I would say from pyplot matplotlib, sorry, from matplotlib import pyplot as plt like this. All right, this is just a function. You don't need to have this. Okay, I just needed to do this for you, then I'll move to the next step. But just to make things a little visual, I'm doing this part. So plt dot plot, okay, let's say dot scatter, plt dot scatter self dot x. Now I'm kind of plotting. It's not like I'm kind of plotting. I'm plotting this. Okay, I'm plotting this function, this point on a graph. Okay, and to plot anything on the graph, you need its x and y. And so when I say self.x, I mean get the x value of this point as x and the y value of that point as y. Okay. The reason why I'm getting this error is because I didn't import, or I didn't add the self to this function itself. So I'm supposed to do that. Any function you create within a class, if you need to use any parameter of that class, then you need to indicate that you need to kind of pass in the instance of that class as a parameter to that function. I just hope I'm not confusing you. Okay, just know that when you add self to this function, it will allow you to access things inside the main class. All right. Okay, so now that we've done this, we can now say plt.show, right? Like this. Okay. All right, and it should work. So now let's say you want to show, you've created a new point, so you could just say new point dot show graph. Okay, so new point dot show graph, and you run it. It's gonna okay, let's see, clear this one first. New point equals, oh yeah, so over here I've already defined what the new point is. It's an instance of the point. So new point dot show graph like this. All right, so when I run this, good, it plots it on the graph. Okay, and it plots it at the x and y points coordinates. So that's how it works. So now let's say I'm going to remove this one. Okay, or should I remove it? So let's say we create another class. Okay, so let's create another class called line. All right, remember I said we want to convert points into lines. Okay, so we create a class called line, and this line takes, so it's also going to take some parameters, right? So we'll call our init state. Let me do it with you. So def underscore underscore initialize, or init underscore underscore self, right? Not mine, but self like this. All right, then below it you can so let's say it takes 2 points. Okay, so let's say point 1 and point 2. All right, because it takes 2 points to make a line, or at least 2 points to make a line. All right, so I could say self dot point 1 equals to point 1, right? And self dot point 2 equals to 0.2, like this. Alright, so what it means is we will have to create what it means is we will have to create points, okay, and then pass these points as parameters into our line class. So how do we do that? Bring this one up a little. Alright, so now we already have a point called new point. I'm just going to make it 2. So I'll call this one new point 1 and I'll call this one new point 2, okay, and I'll give them different coordinates, hopefully like this, different coordinates. Alright, new point 2 like this. I'll remove this one for now. Okay, so now you have 2 new points and we want to put these ones into the line function. So I think let's create the points outside, like in this case, then we put them inside here. Alright, so when we put them inside here, what we are going to have is let's say when I put this point 1, new point 1, let me just call it point 1. What's the use of the new point? So I'll say when I put this point 1, I hope there are small letters, right? I don't want them to conflict with, so I'll make this one small letter P, also this one small letter P, point 1, point 2. Alright, so I'm going to put point 1, point 2 into this line function, okay. And when I put point 1, point 2 into this line function, what I expect is, so let me just say L equals to line, okay, then I give it point 1, okay, point 2, like this, okay. This is what I'm talking about. I'm going to pass them inside the class as parameters, so that I can access their x and y. So I could come out here and I'll say, so let's say you want to calculate, say, their amplitude, okay, amplitudes. So if you want to calculate their amplitudes, that's a function, so you give the function like this. So you take the self, remember, because you'll be using the self stuff. So I could say self dot dx, that's the amplitudes, like change in x, change in y, okay. So I could say self dot dx, or change in x, equals to, so amplitude between point 1 and point 2 means change in x between, so let me write the function down for you over here. Dx equals to x2 minus x1, sorry, x1, like this. Hope that makes sense. Which means we will say self dot point 2 dot x minus self dot point 1 dot x. Alright, that's the first amplitude, or the dx, okay. I could say self dot for the dy, so equals to self dot point 2 dot y minus self dot point 2 dot point 1 dot y, like this, okay. So that's how you compute the amplitude. So I could say return self dot dx comma self dot dy, like this, okay. So you've done so let's do some more properties for this line class. So you could also have distance between 2 points, right? So let's create a function called distance, okay, and I'll pass in self as a parameter, like this. Alright, so if you want to compute the distance, I'll just import math here, okay, math, okay. So import math here. So I will say self dot distance equals to, so remember we computed the x and the y, right? So I could just say, should I do it here? Self dot dx, sorry. So math has a function called hypotenuse, okay. height. Then I'll pass in the coordinates. So I'll pass in the amplitudes, the dx and the dy's. Okay, so self dot dx comma self dot dy, like this, okay. Then I'll return self dot distance. Now you can put these into strings, okay, just to make it look, maybe you could say something like return return distance s, and you put in this, right? So yeah, meters or whatever, just say units, like this. And that's, so basically you can define as many functions as you want to, okay, but I'm just going to end it here. So this line has a property of amplitudes where it computes the differences and it also computes the distances. Let's just try this and see if we've gotten everything right. So 0.1 equals to this and 0.2 equals to this. All right, let's see. Oh yeah, so now I need to, so basically we have 0.1, 0.2, we've passed them into the line class, okay. So what parameter do we need from the line? Let's just say print l dot, so let's say print l dot amplitudes, like this, and let's see, it gives us the amplitudes 31 and 22. That's the differences it got, okay. You can also say print l dot distance, right? We have a distance function, and close the second bracket, l dot distance, and it object has no, okay, sure, you know why. So to do that, I'll just get the results from the amplitudes, okay. So I'll just say amps equals to then I'll call the amplitude function, okay, call the amplitude function, and I'm defining amplitude self dot amplitude, like this. Yeah, then I would pass in amps of, I think, amps of 0 and amps of 1. I think that should do the trick. Let's try that again. Good. So the reason why I didn't get this at first was because we were calling self.dx and self.dy from into this function, even though it had not done those computations yet. So what we needed to do was we will call that function to work, and after that function works, we'll assign the results to this amps, then we'll input those results into this function. All right, so that is how come we are getting the right values now. Okay, so I hope you get it now. You can continue to implement as many as you need. You can implement another show graph function here. Let me know if you are able to implement a show graph function here. I would really like to see your function. So so I expect to see 2 points showing on the graph. All right, yeah, so let's end this video here and then we'll continue later on.